All right, welcome back to another video on triangle congruence and similarity. This one is on how to find missing side lengths in similar triangles. Let's figure this out. So now that we're comfortable with the concept of identifying similar triangles, let's see how they're going to ask us questions on how to find missing side lengths in these similar triangles. Now before we can start this, we have to remember how cross-multiplying works. Now how are we going to use this? Well, if we're told that two fractions are equal, but I have an unknown value somewhere, all I have to do is cross-multiply and then isolate that variable to figure out what it is. So like here, for example, I have 2 over 8 is equal to x over 36. So when I multiply those diagonals, I get 8x is equal to 72. Now to isolate the x or solve for it, all I have to do is divide by 8, and I know that x, that missing number, is 9. Pretty simple, right? Well, that was just a bit of a review. It's going to get a little bit tougher later on, so watch closely. Now let's see 2 examples on how they might ask a question like this on an exam. First up, they love to show similar triangles that are vertically opposite to each other. Now the first thing we have to do here, as in any question with similar triangles, is identify the angles that are the same in these 2 triangles. So I'm going to go ahead and label my vertically opposite angles as matching angles. And then remember, these are alternate interior angles that I'm going to label next. So in opposite corners of the transversals, where they meet the parallel lines, I have my other pairs of matching angles. And watch as I redraw these triangles beside each other, the orientations change a little bit. It's important that you put the matching angles in the same place when you sketch these triangles yourself. Now with the triangles redrawn properly, we can identify easily where the corresponding sides are. So I'm going to set up my fractions with corresponding sides and solve for the unknown. All I need to do here is multiply the diagonals and then divide by what's in front of x, to find out that that missing side length we were looking for is 9.6 centimeters. Now the math here was pretty easy, but setting up this question is what's tricky. You got to make sure you get the orientation right and find those pairs of matching angles. Now in this next question, the setup is a little different and the math is going to be quite a bit tougher, so pay close attention here. What we've got are 2 triangles, one drawn right inside the other, with the top angles lined up and the bases being identified as parallel lines. Now what I'm going to do here is redraw these 2 triangles separately like we always do, with the matching angles identified so the corresponding sides become obvious. Now once this is done, we can get started by setting up the obvious proportion. And this one is that 15 and 24 are corresponding sides. So I'll use that as my first fraction, 15 over 24. So my second fraction has to get set up as x over x plus 6. Now it looks like we might be stuck here, but don't panic. Let's multiply it out and see what we can do. And when I multiply the diagonals here, I get 24 times x, and then I get 15 times x plus 6. Now be careful here and remember, when I've got a number multiplied by 2 terms, I've got to multiply the number out front by the 2 terms separately that I've got. So here I'll do 15 times x and then 15 times 6. Now once I do all this, what I end up with on the left side is 24x, and on the right side I've got 15x plus 90. Now this is actually not so bad. All I'm going to do here is gather my x terms on one side of equals by subtracting 15x from both sides. And look how easy this is. All I'm left with is 9x equals 90. So I'm going to go ahead and divide by that 9 in front of x to get the x by itself. Now of course I've got to divide by 9 on the other side as well. And what I'm left with is x equals 10. So the missing measurement that they were looking for in this question, side AC of that smaller triangle, is just a measurement of 10 centimeters. So when you're finding missing side lengths in similar triangles, remember, find your corresponding sides, set up your fractions, and just be careful with your algebra. We're going to cross-multiply to find that unknown value. Now let's watch a couple more examples on how they might ask these types of questions.